Hi, everybody. So I thought I will go ahead and do some worked out examples for you. Um, so if you look at the screen in front of you, I'm on page 357 out of your textbook. That is section 4.8, which is what we did today. I'm going to do the odd problems. All right. And this is a great video because you could pause it, you can rewind, you can go back and forth if you want. And I'm going to be doing the odd problems. That way you can see how, I'm sorry, I'm going to be doing the even problems. That way you can see how they're worked out. And the odd ones are in the back of the book anyways. So I am just going to go through this. That's it. So on the far right side in red, those are our steps for solving polynomial equations. And our first problem is going to be x to the second plus 17x plus 72 equals 0. So on the right-hand side, set the equation equal to 0. It's already done. Step number 2 is factoring. Since there is no GCF, we have a trinomial in front of the x squared, a equals 1. That allows us to go directly into the multiplication of two binomials. So we're going to put an x and an x. We do our signs next. We need the factors of 72. And in this case, those factors are going to be 8 and 9. All right. 8 times 9 is 72. 8 plus 9 is 17. So this works. Step number 3 is the zero product property. So we set each one of these factors equal to 0. And then we just subtract 8 from both sides. For our first solution is x equals negative 8. For the second solution, we get x equals negative 9. Okay? So let's go ahead. Let's do number 10. So number 10 is 2y to the second minus 24y plus 70 equals 0. Step number 1, set the equation equal to 0. That is already completed. Step number 2, factor. Now in this situation, I definitely have a GCF. In this case, it's going to be the number 2. So I'm going to factor out of 2. By doing that, I extract a 2 out of every single one of these, so I divide everything by 2. So I get y to the second minus 12y plus 35 equals 0. Now I will go ahead and factor. Now in this case, okay, when I factor the trinomial inside, we already did the GCF. Now we have a trinomial where inside the parentheses, a equals 1. So I'm going to go directly into 2 times my two binomials. I'm going to put a y and a y. Get my signs. The first one is a minus, so the second one also has to be a minus. Factors of 35 off to the right. 1 times 35. 5 times 7. And I know the pair that I need are both negative. So negative 5 minus 7 is the negative 12 that we wanted. So this is going to be 5 and 7. Now for the zero product property. And remember, you only set factors that contain a variable. So y minus 5 equals 0. Y minus 7 equals 0. To solve, I will add 5 to both sides to give me y equals 5. And then for the other, I will add 7 to both sides to give me y equals 7. All right. So there's number 10. So let's go ahead. Let's do number 12. So number 12 is 7n to the second plus 14n equals 168. Step number 1, I need to set the equation equal to 0. Currently, this is equal to 168. I can't have that. So what I need to do is take this 168 and move it over here. That way, by doing that, it'll equal 0. To accomplish that task, I subtract 168 from both sides of the equation. That gives me 7n to the second plus 14n minus 168 equals 0. Now that it's set equal to 0, I will go ahead and factor. Remember, look for a GCF first. In this case, total GCF. It's going to be a 7. So by extracting the 7 out, I end up with n to the second plus 2n minus 168 divided by 7 is 24. So I have a trinomial. A equals 1. which is in front of the n squared. That's the coefficient. So I'm going to go directly into the multiplication of binomials, put an n and an n, copy down the first sign as a plus, therefore the second sign must be a minus. Now we need our factors of 24. 1 times 24, 2 times 12. Does 3 work? Yeah, 3 times 8, 4 times 6, and I think that's it. We need the pair that combines to give us positive 2, so that's what we're looking for, positive 2. One of the numbers is positive, the other number is negative, so negative 4 plus 6 is going to yield my positive 2. So we have n plus 6 and n minus 4. Now that it's factored, we will set each one of these terms that contains a variable equal to 0 by using the zero product property. For the first solution, we subtract 6 from both sides. We get n equals negative 6. For the second solution, we add 4 to both sides to give us n equals 4. Let's keep moving. That was number 12, so let's go ahead and let's look at 14. 14 is going to be 64 minus 49 n to the second equals 0. Now in this scenario, there's the first thing I see right off the start, all right, it's equal to 0. That's great. Step number 1, set the equation equal to 0, done. However, in step number 2, we need the factor. And right now, I know this term right here is that's my degree. That's the leading term. So what I'm going to do is I have 2 options. The first option, I can leave it as it is, all right? Or I can rewrite this. So I'm going to rewrite this. I'm going to swap these 2 positions. And by doing so, watch what happens. I get negative 49 x to the second plus 64 equals 0. That's the first thing. Now, hopefully, you can see this to go, well, wait a minute. That's negative 1 out front, all right? That's a negative out front. If I factor out a negative 1, I'm going to be left with a positive 49x to the second minus 64. All right? And that's what I'm going to work with. All right? Because when I look at this, there's no GCF. I have binomials. Right here, this variable, its exponent says number 2. It's squared. So what I'm hoping for is, do I have difference of squares? And in this case, I totally do. So this is going to FOIL. Oh, I just said that word. Oh my gosh, I hate myself. I'm going to rewrite this as the multiplication of 2 binomials. And since this is difference of squares, it will break down into its conjugate pairs. 7x plus 8, 7x minus 8. And from here, I will go ahead and set each factor that contains a variable equal to 0. So I get 7x plus 8 equals 0. 7x minus 8 equals 0. And then from here, I just go ahead and solve. I will subtract 8 from both sides. 7x equals negative 8. Divide both sides by 7 to yield x equals negative 8 over 7. Conjugate pairs means the next answer is going to be x equals positive 8 over 7. And just to verify that, I will add 8 to both sides. 7x equals 8. Divide both sides by 7, and there's the positive side. All right? Now, the other way you could have done this problem, all right, I'm going to write it in red over here. From the very, very beginning of the problem, you could have said, well, I'm going to take this term and move it over here to the opposite side of the equation. By moving it to the opposite side of the equation, you are now making it positive. Then you could have said, well, now I'm going to move this over to the opposite side of the equation. And since 64 is positive on the left, it's going to be negative on the right. So that gives you 0 equals 49x to the second minus 64, which is the same exact thing as right here. All right? So there are 2 ways to approach this. Whatever way you prefer is fine. The idea behind this is we always want that leading term, the degree, to be positive. It just makes life easier. All right, so that's number 14. Let's go ahead and let's look at 16 now. So 16 is going to be 2x to the second equals 3x minus 1. All right, so step number 1, set this equal to 0, which means this term here and this term here, they both have to come over to the left. To do that, I'm going to do this in 2 steps. Or actually, I'm going to do 2 steps in 1. What I'm going to do first is subtract 3x. If you look right now, if I were to subtract 3x, that's going to go ahead and cancel that out. And you can use the word cancel there because it's going away. All right? I'm also going to add 1. Now, remember, here's our equal sign. It's right here. So whatever I do to the left side, I'm going to do to the right side as well. So what ends up happening is I get 2x to the second minus 3x plus 1 on the left-hand side. And on the right-hand side, everything cancels out to 0. Now, I'm going to go ahead and factor. So, no GCF. I have a trinomial. And in this scenario here, a does not equal 1. So that tells me I need to do the AC method. So to accomplish this, first thing we're going to do is get an idea. We know the answer is going to look something like this with 2 x's. Do our signs. They're both going to be negative. So now I can go ahead and do a times c and figure everything else out. So 2 times 1 is 2. Factors of 2, 1 and 2. They are both negative. So when I combine them together with their negative signs, I get negative 3, which is exactly what we want in the middle up here. Okay? So I take this information. Remember, we're doing the AC method. All right? So you cannot just plug these right there. You cannot do that. No. Because you're doing the AC method. So what we need to do is we're going to take 2x to the second minus 3x plus 1, okay? And we're going to separate this middle term into 2x to the second minus x minus 2x plus 1. These numbers right here came from right here. All right? That's where they came from. So now I have a polynomial with 4 terms, and I'm going to factor by grouping. And here's the thing. We must remember we never, ever group that middle sign. That's not going to get grouped. And because this is a negative, that means when we do group, that second sign changes. All right? That looks like a horrible word of changes. So let's go ahead and let's rewrite it like this. All right? So that changes. So let's go ahead and create our groups. 2x to the second minus x minus, here's our second group, 2x, and this is going to be minus 1. Okay? Now we go ahead. Remember, this is set equal to 0. We will go ahead and find our mini GCF for each grouping. So in the first group, it's going to be x. That gives me 2x minus 1. In the second grouping, there is no GCF, and that's fine. This is still equal to 0. Now remember, there is a 1 right here. Our binomials match. Let me highlight that for us. Since our binomials match, we're going to go ahead and factor 1 more time. So we're going to extract the 2x minus 1. That yields x minus 1 left over. And that equals 0. So we finally have our factored form. And we're going to go ahead and set each one of these equal to 0 by using our 0 product property. To solve the first one, I add 1 to both sides. That gives me 2x equals 1. Then I will divide both sides by 2 to give x equals 1/2. For the second problem, or the second part of this, I add 1 to both sides to give me x equals 1. All right, that was number 12, or no, 16. All right, so the next one is going to be 18. All right, where's 18? 18 is right there. So that's going to be 4y to the second equals 14y minus 6. Once again, we set the equation equal to 0. So both of these terms have to come over here. They got to go over to the other side. So we start with 4y to the second. Now, sorry, I had to cough, so I muted myself. So now, that 14y, please note, it is positive. Oops, sorry. Wrong marker. That 14y is positive on the right-hand side. To move it to the left, you do the opposite of positive. So it's going to be negative 14y on the left-hand side. The negative 6 is positive on the right, so it's going to be negative on the left. I'm sorry, it's negative on the right. It's going to be positive. It's going to be positive on the left, so plus 6 equals 0. All right? So all I did to do that is this. I said, I'll write it in red. Minus 14y plus 6. Minus 14y plus 6. These cancel. That gives me the 0, and then everything else is directly underneath, okay? From here, you look for your GCF. Like, that's where it all starts, is that factoring flow chart. So in this case, there's totally a GCF. It's going to be 2. So that's going to give me 2y to the second minus 7y plus 3. Now, I ask myself, all right, can this be factored? Now, this is a trinomial, a not equal to 1, AC method. First thing I'm going to do is break this down, put a y and a y, a minus and a minus, and right here, everybody, right there is the factored form. We just need to figure out what are those numbers inside of the binomials. That's it. To do that, we're going to take a times c. I'm going to do it over here on the right-hand side. So a times c, that's going to be 2 times 3. Remember, it's 2 times 3. It's the inside of the, after you factor out the GCF. So 2 times 3 is 6. Now the factors of 6 are 1 times 6, 2 times 3. And we need negative 7, okay? The only way we're going to get that is right here. All right? So, and this is the key. The AC method allows us to take a 3-term polynomial and convert it into a 4-term polynomial. So that's what I'm going to be focused on, okay? So over here on the right-hand side of the screen, I'm going to write 2. I'm going to write the binomials. I'm going to put a y minus and a y minus. All right? This is our factored form. That's this thing right here. I just want to focus on the trinomial. So 2y to the second minus 7y plus 3 is going to turn into 2y to the second minus y minus 6y plus 3. We factor this by creating our groups. So group number 1 minus group number 2 and remember, this middle sign, I'm going to highlight it. That middle sign is negative, so the positive changes to a negative in the binomial. Don't forget that. Now, in each group, let's go ahead and see if there's a GCF. In the first group, totally, there's going to be a y, so that's going to be 2y minus 1. In the second group, it's going to be a 3, and that's going to give you 2y minus 1 as well. So the binomials match. Let's highlight them. So I can go ahead and factor that. And here is what I need to put. I'm going to zoom out. This is what I need to put up here. All right. So out front, you have the GCF of 2. Then I'm going to write 2y minus 1 and y minus 3. And this is what we solve right here. You only take the factors that contain a variable and set them equal to 0. So to solve the first one, I add 1 to both sides. 2y equals 1. Then divide both sides by 2 to give me y equals 1/2. For the second solution, I simply add 3 to both sides. And that's going to give me y equals 3. All right, that was 18, so let's go ahead. Let's do 20. So number 20 is 3x squared minus 27 equals 0. First equation, first step is already set equal to 0. Done. Step 2 is factor. Here we have a GCF again. In this case, it's only going to be a 3. When I factor a 3 out, I end up with x squared minus 9 inside of the parentheses. There's no GCF. I have binomials. If you notice, the variable says it's raised to the second, and I know we have a minus sign, and 9 is 3 to the second. This, everyone, difference of squares. My favorite type because it's so easy to factor. So I get 3 times x plus 3 and x minus 3 equals 0. Set each one of these factors that contains a variable equal to 0. And then you go ahead and you solve. For the first one, x equals negative 3. And then for the second one, x equals positive 3. 20 is a nice problem. Let's go ahead and let's do 22. Scroll all the way up. We get 9x to the second minus 16 equals 0. All right, we are already set equal to 0. We go ahead and factor. Now, when I look at this, I'm hoping there's a GCF. Unfortunately, there isn't, and that's okay. So, polynomial type, this is a binomial. I look at the variable, look at its exponent, that's a 2. Okay? So then I'm thinking, wait a minute, this may be difference of squares again because I do have a minus sign in the middle. So I look at 9, I look at 16, those are totally perfect squares. So this will factor into 2 binomials. And then all you got to do is ask yourself, what squared is 9? Well, that's going to be 3. So 3x plus 4, 3x minus 4. That's it. Now we set each one of these equal to 0 using our 0 product property. For the first one, we subtract 4 from both sides. 3x equals negative 4. Divide both sides by 3. X equals negative 4 over 3. For the second problem, we add 4 to both sides. 3x equals 4. Divide both sides by 3. X equals positive 4 over 3. All right, so I hope this made sense. All right. 24. Okay, 24. 24 is, and I think we did this one in class, but that's okay. We'll do it again. 34x plus 6 equals 12x to the second. All right. So once again, we need to set this equal to 0. Okay. To do this, notice that the x squared term is over here on the right-hand side. That's okay. More importantly, it's positive. I like that. So what we need to do is take 34x and positive 6, and we're going to have to move these over there to the right-hand side. Hopefully by now, you can see that what I'm going to do is I'm going to subtract 34x from both sides. Remember, 34x is positive on the left. To move it to the right, we do the opposite operation. Same thing with the number 6. It's positive on the left, so I will subtract it from both sides to move it to the right. On the left-hand side, you get 0. On the right-hand side, you get 12x to the second minus 34x minus 6. Now, we go, we follow our flow chart. Is there a GCF? Yes. 0 equals, let's see, I can factor a 2 out. That's going to give me 6x to the second minus 17x minus 3. Now we're going to go ahead and factor the inside. That is absolutely difference of squares again. I'm sorry, did I say difference of squares? I meant AC method. I'm moving too fast because it is 4:41 p.m. and I have other things to do. So just bear with me. So here we go. This is what our answer is going to look like. We're going to put an x and an x, a minus and a plus, okay? So let's go ahead. On the right-hand side, we're going to do the AC method. So we have 6 times 3, which equals 18. Now we need the factors of 18. So 1 and 18, 2 and 9, 3 and 6. The pair that we want has to equal negative 17, and one of them is positive, one of them is negative. So that's going to be plus 1 and minus 18. That's a beautiful thing. And that's going to give us our negative 17. So we're going to take, and I'll do it directly underneath. Let me draw like this nice line. we're going to take 6x to the second minus 17x minus 3. We're going to use these numbers that I just highlighted in pink or purple, and we're going to take that number 17 and separate them. So 6x to the second minus 18x plus 1x minus 3. I put the positive 1 second because I want to make sure that when I factor by grouping, I don't have to change any signs. So going from here, let's create our groups. 6x to the second minus 18x plus x minus 3. I'm already looking here at this x minus 3 binomial, and I can look at that and say there's no GCF there. And that's a good thing. Just remember, there's a 1 out front. You can't forget that. And the first binomial, 6x squared minus 18x, we can factor out a 6x. That's going to give me x minus 3. In the second grouping, remember there's a 1 out front, and there is no GCF there, and that's okay, because our binomials, x minus 3 and x minus 3, match, which means I get x minus 3 out front, 6x plus 1 second. And that is going to go over here to the left. All right? So we have 2 times the quantity, x minus 3, times the quantity 6x plus 1. From here, we take each factor that contains a variable, and we just set it equal to 0. And we go ahead and solve. Add 3 to both sides. We get x equals 3. Subtract 1 from both sides. That gives you 6x equals negative 1. And then divide both sides by 6 to give you x equals negative 1/6. Okay, so that was number 24. So now let's go ahead and let's do 26. So 26 is 2 z to the second. No, I'm sorry, wrong number. 26, 12x to the second plus 5x equals 3. All right, step number 1, set it equal to 0. So I'm going to take this positive 3 and move it over to the left. To do that, positive 3 on the right, negative 3 on the left. 12x to the second plus 5x minus 3 equals 0. Now we factor. There's no GCF. I have a trinomial. A does not equal 1, so I need to go ahead and use the AC method. First thing I'm going to do is at least set up what the answer should look like. So I put x's, plus, and a minus, all right? That's all I can do. So now we're going to go ahead and do the AC method. I'm going to do it over here. So 12 times 3. So 12 times 3 equals 36. Factors of 36 are 1 and 36, 2 and 18, oops, 3 and 12. Let's see here, 4 and 9, 6 and 6. I need the pair to give me positive 5. One of the numbers is positive, the other number is negative. The only way to get that is going to be right here. Negative 4 plus 9 is going to be positive 5. So let's go ahead and let's rewrite this as 12x to the second. Let me draw a line. 12x to the second plus 5x minus 3. That is going to convert into 12x to the second minus 4x plus 9x minus 3. Now we factor by grouping. Create the first group. Create the second group. Please note, I put the positive 9 second because the sign in the middle will be positive. I don't have to worry about changing anything. So in the first grouping, I can factor out of 4x. That's going to give me 3x plus 1. In the second grouping, I can 3x minus 1, my bad. In the second grouping, I can factor out of 3. That's going to give me 3x minus 1. So I know the factored form is going to be 3x minus 1 times the quantity 4x plus 3. That is what I'm going to put up over here to the left. So 3x minus 1, and then 4x plus 3. Okay, I just fill it in. That's all I got to do. From here, zero product property. So I get 4x plus 3 equals 0, and then 3x minus 1 equals 0. For the first solution, subtract 3 from both sides. You get 4x equals negative 3. Divide both sides by 4. That's going to give you x equals negative 3 over 4. For the second solution, we add 1 to both sides. That's going to give us 3x equals 1. Divide both sides by 3. X equals 1/3. Okay? Next problem, number 28. We have 50 y to the second minus 98 equals 0. All right, step number 1, set it equal to 0. Done. Step number 2, we need to find a GCF if one exists. Now, this one's going to be a little bit more difficult, so let's go ahead and let's work out the GCF. Remember, you can always use prime factorization. 50 is going to be 2 times 25. 25 is 5 times 5. So I'm going to write 50, draw an arrow, 2 times 5 times 5. 98. Well, if I take 98 and I cut it in half, I get 2 times 49, and then 49 is 7 times 7. So 98 is going to be 2 times 7 times 7. Therefore, our GCF is going to equal the only factor that is common for both numbers. In this case, the only number is 2. So our GCF is going to be a 2. So let's go ahead and let's factor that out. That gives me 25 y to the second minus 49 equals 0. Now, if you look inside the parentheses, we have a binomial, minus sign, perfect squares. This is difference of squares again. So we'll put a 2 out front. And then we just say, okay, what number squared is 25? Well, that's going to be 5. What number squared is 49? It's going to be 7. So this would be 5y plus 7 and 5y minus 7. The only thing we have to worry about is setting the factors that contain a variable equal to 0. And then from here, we just go ahead and solve appropriately. Subtract 7 from both sides. You get 5y equals negative 7. Divide both sides by 5. You get y equals negative 7 over 5. Since these are conjugate pairs, we know the other answer is going to be y equals positive 7 over 5. And to verify that, we add 7 to both sides. That gives us 5y equals 7. Then divide both sides by 5 to give the positive 7 over 5, which is what we are looking for. And the last problem I'm going to be doing is number 30. So we have 8y to the second plus 6y equals 35. So in this scenario, what we know we have to do is we got to set it equal to 0. So I'm going to take the 35. I'm going to move it over here to the left. Since it's positive 35 on the right, it's going to be negative 35 on the left. And that is going to equal 0. Okay? Now, from here, we have a trinomial where a does not equal 1. All right? So we have to use the AC method. All right? And this one, I'm going to be honest with you, is going to be a little bit ugly because when we take a times c, we're going to get a large number. So I'm going to show you how to deal with that. All right? So first, because we know we're using the AC method, let's at least get an idea of what the answer is going to look like. So we know this is what we're looking for right here. We're going to have two binomials, one positive, one negative, okay? On the right-hand side, we're going to do the AC method. So we're going to take 8 times 35. Now, 8 times 35 is 280. Now, 280 is going to have a lot of factors, so here's what I do. I start off just by writing 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I use just like the fact that I kind of know how factors work, multiplication, division. And I say, well, 1 times 280 is 280. 2 times 140 is 280. Now, the easiest way to do this is to go ahead and take 280 and divide it by 3. So if you do 280 and you divide it by 3, you end up with 93.3 repeating. In other words, this doesn't work. So you just scratch it out. That's all you got to do, okay? Now we're going to continue. 280 divided by 4, that's going to be 70. 280 divided by 5, that's going to be 56. 280 divided by 6, well, that is 46.6 repeating, so that's not going to work. 280 divided by 7 is 40. 280 divided by 8 is 35. 280 divided by 9 is 31.1 repeating, so 9 doesn't work. 10 times 28 is 280, okay? And what we got to start doing here is when we look at this, we need to keep in mind that we want positive 6. One of the numbers is negative, one of the numbers is positive, all right? So, as I start working my way down through these factors, I start looking at things like for example, 1 in 280, no way I'm going to get positive 6 no matter which way I look at it. So, I can scratch that out. 2 in 140, I can scratch that out. 4 in 70, I can scratch that out. I'm going to be scratching all of these out. Even 10 times 28, I'm going to scratch that out, which means I need to keep going. So let me erase all of these real fast. You'll see what I do, because I know none of those worked. Since I already went to 10, now I'm going to go 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So I just got to keep going. That's it. So 280 divided by 11 is not going to work. 280 divided by 12, that's not going to work. 280 divided by 13, that's not going to work. 280 divided by 14, that's going to be 20. And when you look at this, it's like, oh, wait a minute. Wait a minute. If I can just take a step back and say, well, wait, I need positive 6. I know one of the numbers is positive and one is negative. I can get that with these two numbers, all right? Negative 14 plus 20 is positive 6. So the factors that I need are 14 and 20, all right? So let's go ahead. We're going to take 8y to the second plus 6y minus 35. We're going to separate the 6y. And remember, we got a plus sign here, so let's write it second. So 8y to the second minus 14y plus 20y minus 35. Create our groups. 8y to the second minus 14y plus 20y minus 35. For the first grouping, it looks like my GCF is going to be a 2. So that's going to give me 4y to the... Oh, sorry. It's going to be a 2y. My bad. So that's going to give us 4y minus 7 plus, in the second grouping, it's going to be a 5. That's also going to give me 4y minus 7. Since the binomials now match, 4y minus 7 times the quantity 2y plus 5. That is going to go all the way back up here to the left. All right, so let me just zoom out here a little bit. So let's go ahead, let's write those in. I'm just going to rewrite everything so it looks nice. Draw like this little line. So we have the quantity of 4y minus 7 times the quantity 2y plus 5. That's going to equal 0. I set each one of these equal to 0 because of the zero product property. And then I solve. I add 7 to both sides. That's going to give me 4y equals 7. Divide both sides by 4. For the first solution, y equals 7 over 4. And then for the second solution, I subtract 5 from both sides. That gives me 2y equals negative 5. Divide both sides by 2 to give me y equals negative 5 over 2. So I hope this helped. Now you have, like I said, actual worked out answers that you can pause the video, go backwards and stuff like that. If you have any questions, feel free to reach out. See ya.